Hello, this video we will discuss about isentropic process. Isentropic, iso means the same, entropy is S, right? So S1 is going to be equal to S2. They are a constant. So that's going to be called isentropic process. S1 equal to S2. And let's go back to our original equation about entropy change. We have delta S equals integration, right? Integration of state 1 to state 2, and it's a heat transfer over temperature, and that have to be internally reversible process. And if it is isentropic process, if S is a constant, then in that situation, we will know this delta S is going to be equal to 0. Now let's look at this equation. In order to make this to be 0, then we can conclude that it's going to be Q, this heat transfer have to be equal to 0, and then it's also internally reversible process. Okay, so this is very helpful information. Well, we just find out if it is internally reversible process. Also, if the heat transfer is equal to 0, in other words, we call this adiabatic, right? If it's adiabatic process and internally reversible, that tells us they equal isentropic process. Okay, so whenever we see a problem, they said, oh, this is an internal reversible process and also it's adiabatic, then we automatically realize S1 is equal to S2, isentropic process. Or they tell us if it's isentropic process, we know S1 equal to S2. We also know, it's internal reversible process and heat transfer have to be equal to 0, which means it's adiabatic. Okay, that's super helpful what we have over there. Now let's look at this slide here. If it's isentropic, we look at this TS diagram, temperature and entropy. Since S is a constant, so we will have just one straight vertical line, right? S2 is equal to S2. Equal to S1. And what we're going to looking into isentropic process is not often applied for this open system, like such as pumps or turbines, compressors. And if we assume their entropy stays constant and it's going to be isentropic process, we'll have S1 equal to S2, and in other words, we're talking about it's going to be adiabatic and it's internally reversible, which means this is like a double negative, right? No irreversibility means a reversible process. So during an internally reversible adiabatic, another word, isentropic process, the entropy remains constant. Okay, so that is the main message in this video. So next time we will looking at an example for this isentropic process for device like pump or turbines, compressors. Okay, see you at the next one. Bye.